Hello everyone. Before going to doing the simulations, you need to have two files. The first one is my part.step pocket nc2 library.tools. You need to download it from your canvas. Do not use the SolidWorks that you created before. And also I think you also have some instructions file. It is a PDF file. So make sure that you downloaded all of these three files first from your canvas. And then go to Fusion, click on sign in, then a page might pop up on your browser. So I have one account here. I can click on that. If you haven't created an account before, you need to do it first. Okay, so you need to create an account and you need to use your username and password, then you can sign in. And after that, you might see some page like this, and make sure that your license is education license or 30-day trial. But there is another license which is called not for commercial use. So do not use that one. Okay, use either education license or 30-day trial. So in the first step, it might take some minutes or might be seconds, and you can just click on new if you see this page, and we just wait. If before this you might see some other things, you can just click one of them. Do not worry. At the when you sign in for the first time, you might see some other stuff. You just need to click on one of them. That's it. So now we go to here and make sure that your origin is not hidden. Okay, and then make sure that you are on the design workspace. Click on the data panel, this 9 small square, and then there is a place to upload your file. Okay, you need to make sure you might see this data panel, and then you need to upload from one of the file. I have already uploaded, but I will upload it again for you. So you can click here again and then click upload. It might take again some seconds or minutes, and if your computer works well, you might see that in less than 1 minute. If not, you need to do this again. Unfortunately, there are some bugs with this software. I have seen that in a lot of computers, especially in our university. So now it is, and then you need to double click here. So you see this, you see that there is no fillet. If there is some fillet, it means that you are using your own file. So use the file that is on the canvas. So after double clicking on the part, now we need to draw 3 rectangles, which represent the full 42 by 42 by 50 stock cube of actually timber wood. So right click the top surface of the part and you see offset plane. So let us see what's happening. 20 enter. And also you might see another page before this that it will ask you that the unit is in millimeter or inches. So you need to select millimeter. As I said, it is not my first time that I'm using. If it is your first time, you might see those pages. So, okay, now click on the highlighted surface, and then we want to draw a rectangle. We want to create a center rectangle. So it's better to get rid of this by close the data panel here and create new sketch. And you see, this is 2-point rectangle. Okay, so if you click on this, then you have just one options. So I will go to create a rectangle. I will choose center rectangle. Click the center, and now type 42 and press tab 42. Enter. And now press finish. Now you need to go to origin and go to the XZ plane. And go to create a sketch. Go to create rectangle and 3-point rectangle. Zoom in. A lot of people make mistakes here. Zoom in. This is the first, and then by you can see this hand pan. Actually use pan and move the object to the left, and then we click again. It doesn't work. We press escape. Okay, I type 42 again. And then zoom in by rolling the middle mouse button. Again, type in 50. And enter. And then finish the sketch. Okay. For moving the camera, click on the hold the shift button and use the middle mouse button. Now we need to do the same thing on the right side. Click create a sketch, and here we need to click create a sketch. Okay, I double click here. Yes, now it appears. It was hidden, as you see. Now go to find rectangle again, 3-point rectangle. Find this point, type 42. And then click here, type 50, enter, and finish a sketch. Now you need to go to sketches and you can rename them. For example, this one is the right. You can rename it. Make sure that you finish the sketch first. So front, side, enter. Again, rename this side. Plane or side stock side, whatever. And the first one, top or stock top. Okay, now I click on again, for example, these sections. Now I right click in the graphics area and select the move copy and the part, and you need to select the bodies. It should be bodies, not face, remember. And I put the coordinate system here, and we will type in the Z distance 12. Okay. Now to begin the CAM programming for the part, the design workspace, this one needs to be migrated to the manufacture workspace, which is this one. It will generate tool path strategies for the design to be fabricated. And look at here, manufacture. Okay, let us see what is called a stock. In manufacturing, when we say a stock, we mean the raw material block that we start with before machining or shaping it into the final part. Here is an example. Imagine a rectangular cube. Its height is 50 millimeter and the top surface is a square 42 by 42 millimeters. And so this block of material with dimensions 42 by 42 by 50 is called a stock. From this stock, we can cut, shape, or machine the final product we want. Okay, now create a setup by clicking the setup drop down and select new setup. So setup is an important first step in starting your manufacturing process. This selection will help you define the working model stock size. Remember, we need to tell the software what is the dimension of our stock size. Fixtures, if there is any fixture, we don't have any fixture, and set the work coordinate system 0. So available work environment, milling 2 to 5 axis, turning and mill turn, whatever, water jet and plasma or laser cutting, 3D printing or additive. So, okay. In the first tab setup, just go to orientation and change this to the second option, Z-axis plane or and X-axis. Okay, first hold the shift button and use the middle mouse button to show the triangle sides. So the Z-axis should be faced towards the spindle from here. We want to assume that we want to start from here. So the Z-axis should be this way. So if this is the machine, this is called a spindle, or maybe it's here is better. This is a spindle, and the Z-axis of the face towards the spindle should be towards the spindle. So it means that the Z-axis should be this way and the Y-axis should be always upward. And now you see that this one is highlighted in blue, so you need to choose the X-axis somehow, that the Y-axis is upward. Now it is correct, the Y-axis is upward. Okay, now origin should be on a stock box point, and then select box point and choose the corner point of this is the corner of the stock point. Okay, now you move the origin to here. So as there are no fixturing, the fixture box can also be left unchecked. Also the model section can be left as a default. Now go to the stock tab and in the mode choose fixed size box as the stock mode. And this tells the software that the stock is a cube of known dimension. The part will be made from 42 by 42, so the depth Y should be 50. Now look at here, it will be changed if I change this to 50. And this one 42 and 42. Okay, now this translucent yellow box is now slightly offset of the sketches that outline the stock. So this is because the sketches are centered in relation to the hemisphere. Look at here. Let us look at the top surface, or maybe we just click top here. So I will change this to offset from left side X, and it will be 4.5. Now it is centered, you see. Let us move it again. We click on the back here. And again, offset from backside plus Y, positive Y. We choose this one 3 millimeter. And offset from bottom negative Z. So the numbers I read for you: 42, 4.5, 53, 42, 6, and 10. Okay, next move to the third tab, post-process. So the WCS, working coordinate system offset, can be given here. It will set to 1. Because the G54 code will be used to define the work offset on the machine. Click OK. Okay, now go to Manage and Tool Library. You want to import the newly downloaded tool library. Select Manage, and then you go to Local. Now right click here and import libraries, and select Pocket CNC tool library. Go to Tool 10, right click, Edit Tool, go to Cutter. So first change the unit to millimeter, and the length villa holder should be 25. You might ask why we use tool number 10 with a 1/8 single flute Harvey tool. It is suitable for cutting soft materials such as wood and plastic, for this part. So, and why I changed 25.4 to 25, I set this to 25 to make sure that it will not damage the holder. So this is 25 mil. Now click Accept and Close. Now we want to create the tool paths. In this tutorial, we use adaptive tool paths. We click on 3D, adaptive clearing, and this type of tool path, adaptive tool path, actually tries to minimize the machining time, while it will also help to lengthen the life of the tool by taking passes that keep the load on the tool constant. So we have 1, 2, 3, 4, 5, 6 options, 6 tabs actually. So first you need to select your tools from here, the first tab. Select and go to Local. Be careful, don't go somewhere else. And select this tool and again select. So first change the spindle speed to 10,000, because for the softwood we use 10,000. And the cutting feed rate is always 508, and everything will be automatically populated. So let me show you something else. So these are for soft with 10,000 is the RPM. You might ask, okay, why? What is 8,500 for? It is used for copper, aluminium, hard plastic, so and hardwood. And feet per tooth is important, which is in inches, and when we convert it to millimeter, it will be 0.0508 millimeter. So remember, when we enter spindle speed, these two, I mean surface speed and ramp spindle speed, will be automatically updated. And the same as for cutting feed rate, I mean the other will be updated. Sorry, the others will update. So since we do not have any coolant, it should be off. You don't need to check this part. Go to the next tab, which is multi-axis, and click on the tool orientation. If you don't see this option and you cannot click that, you need to use the educational license or another computer. I know that there are some bugs in some of the software installed at the university, for example. Okay, now we want to machine the top surface. So hold the shift button and use your middle mouse to show the top surface first in isometric view. So, okay. The z-axis should be towards the spindle, and it should be perpendicular to this top surface. So I will select, so you see that this is highlighted in blue, the z-axis. So you click, you choose this edge, and you can click flip size. And if you want to get rid of this planes, you can go to view or display setting, and you will get rid of all of them. Okay, now for the x-axis, you can select the, so this is the front edge. Okay, I will click flip x-axis. Now it is in the coordinate, right coordinate, right directions actually. Okay, go to the next tab, which is called geometry. And in the geometry tab, set the define stock. Now it is remaining a stock. It should be changed to a stock bounding box. So the stock has already been set. The dimensions of the stock has already been set during the setup before. If you remember, there was a setup here, setup tab here. Now the toolpath will automatically use the outline of the top of the stock as the boundary for the toolpath. Ensure that the model box is not checked. This one shouldn't be checked. Okay, it should be unchecked. Remember, because it is not needed in this for this operation. So we don't need avoid machine surfaces. We don't need that. We can just click here. Okay, now move to the next tab, height tab. So you see retract height, but the main important one is the bottom height. Let us click here. Now it doesn't look good. So, okay, we just use the pan. Click on the pan. Now you see that these are deactivate. You need to activate them again by clicking escape, because now it is on the pan mode. So, so the height tab is where the bottom and top limits of material removal and safety clearances are set. So you need to scroll down to bottom height sections first. First start by the bottom height sections. You can read some information here. Keep the drop down to selection and click the top surface of the, let us do that. It should be on selection first. Top surface of the part. So, okay, now it will machine until here. It doesn't go beyond that plane. So the plane with the blue edges labeled bottom. Where is bottom? Oh yeah, it's bottom. Should align with the top surface of the part. So now we go to the top height. So we always use a stock type. These planes tells the mill where to expect to first come into contact with material and begin machining. And leave this set this to stock top, and adding a 0.5 millimeter offset will allow for variation in the stock size and provide a small safety factor. No need to change this to value. Go to the next tab. So this tab controls how much material is removed at any given time. We use the default values in the passes tab, and in the stock to leave 0 millimeter for axial stock to leave, and 0.5 millimeter for radial stock. So if we change to 0, this means that in the axial direction, the cut will be all the way to the defined heights without leaving extra material for the finishing pass. On the other hand, 0.5 millimeter of material perpendicular to the tool is kept so that there is excess material left around the hemisphere for cleaning up with a finer operation for a better surface finish. So we just leave this 0.5. Now we go to the linking tab. Okay, first change no engagement feed rate to 1000. And what does that mean? Because it saves the time when the tool's in a retract and not cutting. So the helical ramp diameter can be changed to 1.27. And ramping angle can be changed to 10 degree. And remember, 2 degree is good for aluminium, copper. But for the softwood, we use 10 degree. So click OK to finish the tool pass. So a tool path will be generated. For view, the lines represent the movement of the tool, and the green block represent the amount of stock remaining after these operations. If you would like to view the motion of the tool path, go to Action drop downs and go to Action drop down, click Simulate to watch a video of the operations. Let me increase the speed. And next, a radial tool pass will be used to add a finishing pass to the hemisphere. This tool pass keeps the cutter in contact with the part and uses paths that are equally spaced radially, remember, radially, around the selected center point. So select the radial tool pass from 3D, but first you need to exit simulations. So here you see radial. Okay, you need to select the same tool as before. Go to local. Do not choose any other thing. And I think it was 10. And change this to 10,000. $508. Okay, now go to multi-axis tab, and again check the tool orientation. Okay, the z-axis should be upward. I select this edge and flip axis, but now select for x is also. Let us flip the z-axis. It should be upward, and the x-axis should be this way. Now go to the geometry tab, and here select the bounding box, and I think it's better to change it to selection. And here in the machining boundary selection, we will select the base. So I just need to select this contour, not the whole face contour. So I will click cross here. I will select again, and I will just choose this closed chain 1. Okay, it is a closed contour. Okay, then set the tool containment to tool outside boundary to ensure that the tool stays to the outside of the selected geometry instead of cutting into the hemisphere. And the slope setting box should be set to, first should be checked, and from a slope angle 0 to 90. Now go to the heights and bottom height, change this one to selections and select this surface, and change the top height to 0. Let me first show you what's happening here. 0.5. Now move to the passes tab. An angular step of 2 degree, step size of 2 degrees will work okay for these applications. The closer these passes are to one another, the better the finish will be. But if they are farther apart, the path will take less time. Okay, go ahead to the next tab, linking tab. The settings in the linking tab can be left at the defaults. Click OK. Now you can go to Action, Simulate. It was very fast. Let me. Okay, you see that this radial passes, actual tool pass. Now exit the simulations. Okay, we finished machining of one surface, the top surface. Now let's go to the next one. Go to 3D adaptive clearing. So you see that it is the same as before, 1508 and disabled, the same tool. Go to the next tab, Tool orientation, click here, and let's move this. So the z-axis should be, we select this edge, and for the x-axis we select. So actually the z-axis should be perpendicular to this surface that we have the recess. So I will select this again, select this edge, and also y-axis should be upward. It's correct now. Okay, now go to the geometry tab. Okay, change the machining boundary drop down to selection. Okay, now change the tool containment to tool inside boundary. Okay, now we need to go to display setting here, object visibility, and now we will select this plate, this rectangle. Okay, you might ask why we select the rectangle sketch. So this sketch was created to constrain the tool path so that the tool has plenty of clearance from the vise. If you don't know what is vise, this is vise. Now in the define stock by, in the stock definition, choose the stock bounding box. You can also click here. Okay, now go to the heights. So first change the bottom height from to selection and select this surface. We will change the offset to 0. Now go to the passes tab. Okay, we will change the maximum roughing step down to 2.54 millimeter and fine step down to 0.127. And this is because the protruding lip of the board is short. From here to here is very short. And using a final resolution will allow the toolpath to face off this feature. So we will turn off the stock to lip because there is nothing to finish after that. There is no need to add an additional finishing pass. Okay, in the next tab, okay, adjust the no engagement feed rate to 1000 and the ramping angle to 10 degree and helical ramp diameter to 1.27. So when simulating the tool path, there are a few items worthy of noting. The first is that as it is a 3D adaptive clearing, the tool path will recognize the raised lip of the circular hole, this part, and remove the material from inside it. A 2D adaptive clearing would not recognize this without selecting additional contours. And the other point is to note is that while the center of the board is cut, it is not cut to full depth because the bottom height was set to the main face of the part. I mean here, not here. Okay, let me show you. Yeah, here. As a result, another operation is needed to cut to the full depth of the bore. Next, select, now we click OK. Now select the 2D bore from the 2D drop down menu and reuse the same tool parameters. Now in the multi-axis, check this. So the z-axis should be, select this edge, and for the x-axis we select this x, yeah, and it should be upward. And in the geometry, which is very important, select the inner wall of the circular recess. Okay, let us get rid of this. So now you select this. Now go to the heights tab. Again, should be 10, 5, 0, and 0. No need to change anything. Go to the passes tab and leave all of the defaults as they are. Can't. Now go to the linking. Again, no need to change anything. Click OK. And you can see that the material is gone here. Okay, with the circular and bore side complete, the triangle side will be machined next by using a 2D face toolpath, and then cut the recess with a 2D pocket toolpath. Let us find the triangle side. Okay, firstly, a 2D face toolpath is used. So remember, the reason that I didn't use adaptive clearing, because adaptive clearing is used for larger amounts of material removal. While facing, I mean this 2D facing, removes all of the material on a given plane with a back and forth motion, which is best suited to flat faces like here. Let me show you something again. So when we go to 2D face, you see that it says that produces quick part facing to prepare raw stock for machining. It is quick. It is the same as before. Go to the next tab. So this one is correct because the z-axis is toward the spindle and y is upward. Go to the geometry. Okay, now we need to select the sketch stock size that we created before. That it also encapsulated the triangle side. So let me show you something. So let me open all of this for you. Now also, these are the sketches. I just click on the my part. But let me show you something. Visibility. Okay, I need to select this rectangle. Okay, some people might say, okay, why you didn't, let's get rid of that. Why you didn't select it from here? It would be the same, but do not select this side, okay? Now you selected two items. So we select this side, we go to the heights now, and we change the bottom height to selection, and we select this surface. Okay, the retract height should be changed to 10. The next one 5, and so 0.5. Okay, let us show you. Now we go to the passes tab. Now we check multiple depths, and maximum step down should be changed to 2.54. And now go to the linking tab, and the linking tab can be left as default. Click OK. Okay, let us see what's happening here. Next, use a 2D pocket toolpath from the 2D drop down, but it creates a roughing operation that uses the toolpath parallel to selected geometry. This one you don't need to change anything. Go to the next tab, tool orientation. In the multi-axis tab, z-axis perpendicular to the face, that is to machine, and pointing away from it. Okay, the y-axis upward. In geometry tab, so you need to select the bottom edge of the surface. You can go to here, an object visibility, get rid of everything, and now select the bottom edge. And in some cases people can do this, and then it will be a closed chain, and you see the directions. And in the height tabs, actually it's better to select it as a closed change. Okay, you might try the other way that I said, just click just this face and show me the result later. In the height tab, set the bottom height to the bottom of the recess. So we will change the bottom height to selection. And it should be 10, 5, and top height can be 0, 5, 10, 5, 5, 0. Now go to the next tab and go to the multiple depths and change the maximum roughing step down to 1.5. And the remaining options can be left to the default setting. Uncheck a stock to leave because the full recess is to be machined. Now move to the next tab. So change the ramping angle here to 10 degree and the minimum ramp diameter to 1.27, and and also this 1.27. Okay, now we can just click OK. So we have another two surfaces. We can use 3D adaptive clearing. We don't need to change this. Tool orientations. So z-axis and the z-axis should be upward, and the x-axis can be this. The z-axis actually should be that way. Sorry. Now go to the next part. We use the stock bounding box. Let us show the features. I will select this rectangle. Okay, first it's better to change this to selection. And we select this rectangle. Or let me also minimize these things. Now we go to the next tab, height. This one should be changed to selection again. Select this surface. We just, for the offset, we put 0, 10. Now go to the next part. So stock to leave, we uncheck this part again. Let us see what would happen here. Change this to 10. Okay, now we click OK. You want to see what would happen. Go to the action. Go to simulate. Okay, it's finished. Now exit simulations. Now we go to this part. Again, we go to 3D adaptive clearing. So it is the same, the tool tab. We go to the multi-axis, tool orientation. The z-axis should be this way. Let me change this a little bit. And the y-axis should be upwards. So we choose bounding box. Let us this time just choose selections. If you choose selection for the geometry, you don't have a lot of options, I think. So we just use the bounding box and tool inside boundary or outside. We'll use outside first and define a stock by the remaining part, remaining stock. Go to the next part, which is height, selection, and choose this actually surface. It should be surface. Yeah, face, sorry. And change this to again 0. For the passes, make sure that get rid of this part and change this to 10 degree. So we go to action, post process, and we select Penta machine. Okay, and then you can put the name here, for example, Sayed. Put my name and number 1. Make sure that this output folder is correct. And we will use meshing configurations here. Again, you can type here NCV22 to 10. And we will select this. Must be downloaded. Okay, we download everything. Yeah, the same. And when you go to the multi-axis, rotated work offset should be 9. And then post. You can also click on the open design. You can see the machine. This is the spindle part. And now you can go to the folder and you can see the G code. So the next step is set up and running the program on a 5-axis CNC machine. Okay, well done.